All right, so it's kicking off time. Oh, yep, there we go. I'll look right this too. All right, so it's kicking off time again here. Our last session for afternoon tea. We've got Rob. Rob, how far was the trip for you?
It took about 2 days from the east coast of the U.S. So through Hong Kong.
Through Hong Kong. So,
Yeah. So 16 plus 8. Yeah.
Easy, right?
Easy.
And you're flying back
Tomorrow.
Yeah. In and out, easy trip. Hope everyone's very thankful Robert's here. Please join me in welcoming Robert.
I spend a lot of time working on AI stuff professionally. I use AI in real projects. I build AI tools. That's actually what I'm mostly working on these days. I talk to a lot of people from a lot of different companies, and I try to collect what's working, what's not working. And that's what I want to talk to you today about, is mostly about what AI is not good for, but also what it can be. Right? I don't plan to change anybody's mind today. If you hate AI, I respect that. I actually kind of like it myself, but I spend a lot more time stopping bad projects than starting good ones. So I hope maybe this could help you do the same. If you love AI, then I hope maybe this could just, then, is that better? Then I hope that maybe this can keep you from making the same mistakes I've seen happen over and over again. Anytime we talk about AI, it raises this question about what words we should use. So I'm going to say AI, even though that just covers one thing. I'm going to mean by AI what everybody means by AI right now, right? It means large language models. There's a lot of other things that are AI that I think actually we need to focus on more, like old machine learning things actually have a lot of applications, but everybody talks about LLMs. We're going to talk about LLMs. I'm also mostly today, I'm talking about generative AI. So there's also kind of more the chatbot-y kind of AI where you ask questions, get answers, and things like that, which I actually think has its own good sides and bad sides. I'm not going to talk about that as much. I'm mostly talking about where you take AI to get a real product out, like coding. And I'm mostly going to be talking, or I'm exclusively going to be talking as a programmer to programmers. I don't know how this affects people in other fields. I'm not in those fields. The verbs we use are also really important. What does an AI do? Is it thinking? Probably not. I'm not a philosopher. Most of us here aren't. I don't know that I'm thinking. I don't know what it means. But what I do know is that we are human beings and we use metaphors to help us understand things. And when I say that my car wants to pull to the left, nobody gets upset and says they don't have an inner desires. It's like, yeah, I know. It's chill. It's okay. We're using metaphors today. When I say an AI gets confused, it's a metaphor. But AIs do not behave like people in a lot of very important ways. And I do see people push the metaphors too far, and that leads to confusion. So we're going to hopefully get through some of that. Okay, what does an AI do? You know, this is what an LLM really is at the end of the day. Assembles a context, it applies the model, we'll talk about that, to generate a list of ranked tokens. We select a token, we put the token at the end of the context, and we turn the whole crank again until it says done. Let's walk it through. The context. This is probably, if you're working in the AI world, this is the most important thing you will ever deal with. The context is an LLM is a mathematical function. I'm going to say this about 4 or 5 times in this talk. Mathematical function. It takes an input and it generates an output. The input is the context. The context is everything that has gone so far in this session. That means it is every document you have attached, all of its contents. That is all the source code files that you have attached to this session. It is everything you've said, everything the AI has responded, every tool, all the output, all of it. That is the context. It also includes things like the thinking tokens, and we'll talk about those. Anything that's not in its training data is the context, and it is a giant thing. It's about the length of a medium-sized novel, maybe 2 novels. It's between 200,000 tokens and 1 million tokens. But the important thing is, it's literally a value. It's one giant vector, and it's treated as one giant vector. The values are tokens. So when the numbers here all represent a sequence of bytes. So we have this ST is represented by 302, but capital STR is represented by 3504. Space strawberry is represented by 101,830. These are all from GPT 4.0. Different ones have different ones. But the important thing is a token is a word, or sometimes a part of a word. ING is usually a token. They are highly tied to the languages that the system was trained on. And in English, they represent 4 or 5 letters, usually. Although, as you see, Space Strawberry has its own token, so I mean, it's all over the place. These tokens are converted into embeddings. Embeddings are also vector. Everything here is a vector. Everything's a vector. They're just numbers. And the point of these embeddings is to map all of these tokens that are kind of the same, like all those things for strawberry, they're all kind of the same thing. You would hope they all point to kind of the same place in this high dimensional vector, because they're all kind of the same. But the ones that started with a capital S, there should be a little bit different, because that's different. That means it's either the beginning of a sentence, probably, or maybe it's a name, which is a little bit different. Embeddings capture all of that kind of very careful semantic information, including maybe it's this. All that stuff is captured in this giant high dimensional vector. Why this is important is that's the thing the LLM works on. It barely sees tokens. It absolutely does not see letters. That's why it can't count letters. It literally doesn't see them. They're not part of the thing it works on. You're asking it to do like the hardest thing it can do because it doesn't think like you do. Now, the context vector is, and this is, matrix, format. It takes all of these tokens and spits out a list of what's the next thing. So we start with the capital of France. You'll notice these spaces in front because white space is not special. It's just part of the token. The capital of France is what should be the next token. Paris is the most favored token in that scenario. I actually pulled this again out of ChatGPT. But then maybe we should have 2 stars, or a colon, or the capital of France is known, or a quotation mark. Like, these are all options for the next thing. Now, this, given the same context, you will get this list out every time. Despite what you've been told, LLMs are 100% deterministic. It is a mathematical function. There is no random numbers yet. There will be in a second, but there are no random numbers at this point. So everything here, you will get the, in, out, math. Now, once you have that, though, now is when a little bit of randomness can sneak in. We need to pick one. Now, the easiest thing to do is just pick the first one, Paris. LLMs actually work better if you don't always pick the first one. It just, they actually work, they get to hook directly to their input data if you always pick the most likely token or the best token. So you can tune it to say, maybe pick a different token sometimes. You can decide how much randomness you want, and it's a parameter called temperature. But if you set the temperature to 0, you will always get the same answer for the same input every time. However you pick those tokens, that token gets stuck at the end of the context. You turn the whole crank again. Yes, you're going, wait a minute. We're going to reprocess hundreds of thousands of words. Yes, you are. There are some optimizations. It's not exactly as bad as that, but it's actually kind of as bad as that. That is why it is so computationally expensive to do this. Every individual token is a complete or near complete computation of the whole system. Eventually, the model emits a token that says, done, and then it stops. It chooses when that would be the right token. And end of message is just another token. I mean, it's not even a particularly special token. So what's missing in all that? Well, how does the model know what day it is? It doesn't. That actually is really important. People get confused about that all the time. The model has no idea what time it is. And people often rely on it knowing. How can it know? It has to be in the context. Without the context, it has no idea. Also, has it read a file or search the web or any of this other stuff? It can't. It's a mathematical function. What it can do, and we do mostly through prompting, we actually tell the LLM it gets handed to it, here are a list of tokens, LLM, you may emit, and if you do, I will run a function for you. So this is usually done at the level of like Klein or Claude Code or like these kinds of levels of tools. Actually, so well above the model, tell the model, emit this sequence, run a command, and then it gives a long list of here's what the command would be, here are the parameters, here's what I'll return, and it says, and then the system can decide, or the LLM can decide, I'm going to emit read a file, and here's the file name. And then it's done, and Klein is going to go off, read the file for it, add it to the context, and turn the crank again. The model itself does nothing, does none of this. It just has it. And you might go, wait a minute, does that mean I could just inject stuff into the context? Yeah, absolutely. And it cannot tell the difference between, you can tell it that it asked for things, that it didn't ask for it. That's actually an attack on LLMs. So all of those things are called tools, if you ever hear the term tools. A tool is everything's a tool. Even things like thinking. AIs don't think like people. I don't like the word thinking because it doesn't really match what they're doing, but I don't know a better word. It's not like there's a great verb. Thinking is often implemented as a tool, or it can just be a special token that says, I would like to think now. And so in some cases, it's essentially an XML tag that says thinking, close XML tag thinking, or very close to that. All it says is, I'm going to start emitting things into my own context that the user should either not see or should see only in maybe a different UI or a different style. There's all these little thinking tokens. It's literally it talking to itself. Weirdly, this works. We don't know why it works, but it does work. It makes them work a bit better. But you shouldn't think of it as its thought process. We know from research, we know that the final output may not match what was in the thinking tokens. We don't really know what it's doing when it emits thinking tokens, but all it is doing is emitting more tokens into the context. Remember, the context, the whole system is stateless. It has no inner state that's being mutated. The only place it can store information is in the context. So let's talk about hallucinations. I don't like the word hallucination, but it's the word we use, so let's just use it and stop complaining about it. I agree, some psychologists have said the right word is confabulation. I agree with them. However, I don't care. Language does what language does. So we're going to call them hallucinations. What does it happen? Why does it happen? First, I want to be super clear, there is no such function as make stuff up. Telling AIs to not make up stuff is not a thing. They are not making things up. They are filling in information they don't know, which is what they always do. They can't help it. That's how they work, right? So the training data is not all in the model. You can kind of imagine they were trained on a lot of data, it's not going to fit in the model, right? The model is much, 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 much smaller than the training data. A reasonable way to think about it is like JPEG compression. It's not quite true, but it's not wrong. So imagine an image that you've JPEG compressed, and then turn the quality down and down and down and down and down and down until everything fit. It's going to be okay. It's going to have certain areas that are perfectly visible and understandable. It's also going to have straight up artifacts that weren't in the original image, because that's how JPEG works. And this also is a type of compression, sort of, that has to fill in information that it doesn't have anymore. And it bases that on natural, logical things to fill in the gaps. Now, this is not unique to AIs. We do this too, right? Confabulation is, and the reason confabulation is good is because it matches to what human beings do. When we don't remember things perfectly. We don't see things perfectly. We don't hear things perfectly. We're constantly filling in and going, well, I'm sure they actually said such and such, right? Because those are the words that make sense for them to have said. AIs do the same thing. And the point of all this is, an AI is not a natural language interface to a computer. That is, people often think that. That is not what's going on. An AI is a terrible computer, kind of in the exact same ways you are a terrible computer, right? And kind of for the same reasons. An AI can kind of do math, but it's not a calculator. In fact, we don't know why they can do math. It doesn't make sense. We did not teach them to do math. There is no math function. It's just at some point, they started doing arithmetic, kind of poorly. No one knows why. What does this mean? This tells us if you want something that is a computer, write a program. AI is not a computer. AIs can use computers. That was what tools were all about. That's actually giving an AI a computer to use. I don't know, for instance, why we don't just give them a calculator, because we could. I don't know. We really should always give them a calculator. Now, most of my AI tools, so I build AI tools all day. That's actually most of what I do these days. Most of them, however, are almost entirely non-AI. There's no AI. They're just Python scripts whose job it is to collect data, get them all massaged and figured out in things that are highly deterministic, and then for just the part that's useful that an AI is best for, give it to the AI. And then get an answer back. I don't usually use tools or MCP servers or any of that stuff. Or even conversational prompts. I just figure out everything, hand it to the model, get a response back, because that's the thing a model is good at. And we'll talk more about what kinds of things models are great at. Important thing, AIs do not learn. So MIT released a study recently, found 95% of all the CEOs they talked to, the organizations they talked to, who had put out big AI projects, had no value from it. Number one complaint, or one of the top complaints, was this one, that AIs don't adapt. They don't learn and they don't grow. Folks kind of expect an AI to be like a new employee, and you could work with, at the beginning they're kind of green and they'll make a bunch of mistakes, but you use them for a while and they get better and better. AIs can't do that. Remember, it's just context. There's nowhere to learn anything. Unless you stick it in the context, which is a quite limited resource, there's no way for it to get better. And this really confused people because they expected it to improve, kind of organically. And AIs are very not organic. You also can't just keep chucking things into the context. Not only is it small-ish, it's big. 1 million tokens is still quite a lot of space, but it's not that big. But if you put things in the context that aren't relevant to the current question, they tend to confuse the AI. So you actually want the context to have only information that is relevant for this exact prompt. Common mistake, people just chuck things in there, and then they're like, the AI just goes off the rails. It's like, don't tell it so many things. The model was frozen at a point in time when it was created. When there was a release of whatever, Claude, whatever, it's like, it's frozen. And there might be fine tuning, later, but then it's frozen at that point. It's not like day to day anything happens to make the model learn. And every time you start a new session, all the context is usually thrown away. So you start all over again. So there are these things, knowledge bases and RAGs and vector databases and what. There's all that, but they don't act anything. Even though they're called memory systems, they are nothing like human memory. I wish we wouldn't call them memory systems. We should really call them search systems, or they're really just a search system. It's like a web search. A knowledge base is something that holds a whole bunch of information that the AI can emit tokens to make a tool request to say, I would like to search for something about this topic. And they're usually semantically searchable, and that's really nice, but it's just to put things back in context. Until it's in the context, it can't operate on it. A huge thing that's missing, humans have a really unique thing in memory where you go, I knew that. I should go look it up. Or, you try to think really hard to remember it and you get it back into your working memory and then you remember it. AIs have nothing like that. If they don't, it's either in the context or they have no idea it ever existed. Also, saving a new memory, creating a memory, is an active step. It's a tool. And AIs are they don't like to do it. I don't know why, but they really don't. I use ChatGPT almost every day. I have the memory feature turned on. I've been using it for months and months and months. It has 8 memories stored, and 4 of them are outdated. So they don't naturally store memories. AIs don't dream, right? So that's the thing that humans do. We kind of have an organic way that we process everything we did and grow. AIs don't do that. And the AI also has no particular knowledge of itself. They don't self-inspect. This is a huge thing because they sound like they do, but what they're doing when you ask, why did you do that? They are looking at their context, which is the only thing they have, and they're making a plot, because they don't remember, it's a model, it just has the context that says, you said this, you thought this, you did this, bum, 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 bum. At the bottom, the user says, what were you thinking? Well, imagine I just handed you a transcript of somebody else. It's not you. It's now your job to figure out what they were thinking. And that's what the AI does. It's kind of like asking your kids, why did you do that? They'll tell you something, but that doesn't necessarily mean that's what happened, right? So it's not really self-reflection. And I find the same thing. AIs are not necessarily that great at figuring out how to improve their own prompts. Sometimes they can do it, but it's not because they think, how would I have... So you have a theory of mind. You can actually picture your own mind and other people's minds and predict what you would do in a situation. AIs don't have one of those. What they do have is training in best practices. They've read papers about what makes AI prompts work, so they can apply those. But they're not talking about themselves. They're talking about AIs that they've learned about. Very, very different. So my favorite story of that is I was using this agentic system called Q, Amazon Q. It's a command line tool, chatbot. And I was like, do you have I wanted to have an extra command line option. I thought there was an option to do something. I can't remember what it was. But I was like, so I asked Q, do you have an option to do this? And I thought I'd get an answer. Instead of getting an answer, I got a tool request. It said, may I run a command? And I said, yeah. So it ran Q -- help. It then read its own help system. It then came back and said, I don't think I have an option to do that. It's the most passive-aggressive answer I've ever gotten. Okay, so an AI is not a computer, and an AI is not a person. It's kind of a quirky tool. It can be tricky to figure out how to use it. So let's talk about that. Personally, let's talk about coding tools. Cline, Code, these things. I frankly find them more trouble than they're worth 90% of the time. And I retry to use them all the time. For a complicated existing code base, they spend a lot of time messing with it, and they write way more code than I wanted. And I spend more time undoing it. I don't like it. I find you can prompt them enough to stop, but I find by the time you prompt them enough, you might as well have just written it. right? So many things are like that with AIs. When you find yourself, well, you should prompt it better. Well, maybe you should just do the thing then. I mean, if it's only going to be a one-time use prompt, most of my things are developing prompts that will be used over and over and over again in automation tools. Well, one-time prompts, why are you spending an hour prompting for something that would have taken 15 minutes to do? Anyway, I'm not a big fan. I follow a lot of vibe coders, and I've done vibe coding myself, and I followed this exact same arc. I was like, this is the best thing ever. It is doing awesome work for me. And then I realized, I looked at the code, and I was like, oh my goodness. I mean, it runs, but as soon as things start getting a little more complicated, you start adding more features, it starts making a complete mess of it. It gets itself very, very, very confused. You can avoid that by carefully reining it in, but then you might as well just write it. I mean, the way you rein it in is you basically already have in your mind exactly what you would do, and you make sure it does exactly that. Well, that was the hard part. Typing really wasn't the hard part. And also, AIs are shockingly slow at typing, when they are in coding tools. They're really fast in like chat interfaces, but they spend a long time messing with your code. So I have this rule. Anytime I see somebody posting a thing like, woo, I have this new awesome tool, I ask them in 2 months. I set a reminder 2 months later, just ask them about it. It is very rare they're still using it. That's it. I have found AIs to be very good at writing small bits of code. I don't usually use agents for that. I just cut and paste and then say, how do I do this? Or just put the signature and say, just write this. And then I can see it, and I find they're really fast at that. I like that. I often take like a 30-line method that I've made kind of a mess of, paste it in, say, simplify this. That's a whole prompt. I get 5 lines back. They are in fact better than what I wrote, and it found 2 bugs. It's a good. I really like AI as a code reviewer. Every time I review someone's code, I let an AI review it in parallel. I'd say about 30% of its findings are actually completely wrong, and in many cases flat out backwards. That's why I do not like necessarily to put it in the CI system or directly into GitHub, because it confuses people, because it can just be wrong. It's also why it's hard to have an AI review an AI and like make a loop, because AI reviews are often wrong. But we could ignore those. 50% of them are the same things I found, which is actually good. That means that it having a lot of overlap with a human reviewer means it's doing a good job. 20% though are things I missed, and that's amazing. Where it's really, really good is finding bugs in your error legs that you skim over as a human. Cut and paste errors in string constants. It finds those really well. Again, humans tend to like overlook those. It's all those little places that the documentation doesn't match the implementation. Again, the kind of thing that human reviewers tend to just assume are right. It will actually look. Now, partially it looks at those things because I tell it to look for those kinds of things, because I found that AIs are good at finding those things, and they are things humans are bad at finding. So I tend to encourage it in my prompt, hey, here's some things to look for. And then we're working in concert. That's the goal. And again, I was just saying with the self-cycle, they tend to not be that great at reviewing their own code, or even 2 AIs reviewing each other's code. It's kind of okay with a human being carefully in there, but they're wrong too much. And also the kinds of mistakes they make aren't quite the kind of mistakes they find. So even if they're different models, I don't like it. It's not scalable. So here's the thing. The number one thing I see people want to do, they want to replace tests with AI. Please stop it. Please stop it. Stop it. It doesn't work. AIs are very, 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 very good at writing tests. They are terrible at writing useful tests. So here's the thing. One way we can do it is we write the code first, and this is the number one way I see people do it. They write the code first, and then they want to commit it, but they want their code coverage numbers so they can have their little number that says, yay, you're a good programmer. And so they say, Claude, write code tests for me. Yeah, this is terrible, because the tests you get out, because it's looking at the implementation, they are hyper tied to the implementation. What you wind up with is a bunch of tests that say the code does what the code does. that is not useful. And when anything changes in the future, so you have all these tests, dozens of tests, the least thing changes, boom, you have to fix dozens of tests. And please don't say, have the AI fix the tests. We'll talk about that more in a second. This is the one that people love so much. They get so giddy at the beginning and so sad about 6 weeks later. The other way we can do it is we can do TDD. And a lot of people advocate TDD with AIs. I don't think it works. It still doesn't work. Because you have to review these tests very carefully. You need to review them like you're a lawyer looking for loopholes that the other side is going to exploit. Because AIs will exploit every loophole in the tests, right? They will write the funkiest tests. So I find test code like this to be really, really hard to review. Because test code is weird, right? We all know it's just not like normal code. And it's really hard sometimes to see what it's testing because it's kind of this negative space thing. So the other thing is, it's hard to have the AI write the tests for you because the tests define what the program does. They're the prompt. That's the thing you were supposed to write. You know, it's asking, it's essentially you wrote the code and then you ask the AI to write a prompt for it. It's like, that's kind of backwards. So in really simple code, it's fine. But the moment they need a mock, oh my goodness, they will find a way to get a mock in there. I mean, they see the word test and they go, mock! And then they're like, maybe I could have 2 mocks. And even if they already have a mock for that exact thing, they'll make a new mock. I have had it be, there's literally no code being tested left. It is only mocks in the entire test case. Oh, good grief, they will mock so much. Again, and this code is a nightmare to review. I don't like it. And then, oh, this is my favorite. This is real life. I mean, this is from memory. It's not a direct quote, but it's very, very close to a quote. An AI goes in and you say, well, let's have it fix tests that are failing. This should return, this is the comment the AI wrote. When it changed the 5 to a 4 in the final line of code. Yeah. I have seen it. This is real life. It was in fact 5 to 4. It's like, I don't know, it just returns the wrong thing. And the test has to pass. And this made the test pass. Done. I love it didn't even mark it to do. It just, nothing. Anyway, it also, I've seen it go the other direction, where it will, in the live code, it checked whether it was a test account and hard-coded the right return. Let that sink in. Don't let them write the tests. Keep them away from your tests. That said, again, like with code, I think that they are much better at reviewing things than writing them. They are actually pretty good at looking at your tests and saying, hey, these are duplicate. Like you're over-testing something. Or especially finding cut and paste errors, because cut and paste errors happen in tests a lot. They're good at that. And if you do have a whole bunch of tests that are really, really, really similar and you've already written 2 of them as examples, it can fill them out, but I rarely find it worth the trouble. Just cut and paste it and then ask the AI to make sure you didn't make a mistake. On the other hand, AIs are fantastic at writing test data. I love them for writing test data because they can write, like most of my test data looks like user 1 from any town. They make like really legitimate looking test data. But what I love even better is they can corrupt your test data in specific ways. You can say, take this and break it, like do things to create errors. So yeah, I'm all for that. Speaking of breaking things, I'm not going to talk about it at length, but search for mutation testing. This is a thing I think that AIs will be able to make practical. Basically, you modify things and see if your tests break, because they should. Because AIs are good at writing bugs, so make them write bugs. After test, the number 2 thing I see is people want to write documentation. That I'm not going to rail against. It's a mixed bag. There's good and bad. There is a value, there's a big value in letting AI write to kind of explore your code and write high-level architecture documents. If you carefully read them and revise them. Every word, you need to read the whole thing, not just skim it. You need to read it and fix it. You also kind of need to carefully prompt it because AIs really want to just write how to install a Swift package as the documentation. You need to tell it what you're looking for. Maybe show it. But the nice thing about doing this is first thing you can see is if it writes too much, you go, I can't review all that. Well, then nobody's going to read all that either. So it's not really useful. Tell it to be more concise. The point is to create documents that are useful, not just to create words. If the AI is making a lot of mistakes, that probably means your architecture is too confusing, right? If it's confusing the AI, how your program works, your coworkers are probably confused too. Maybe you need to fix your AI, or fix your code. Or you need to write some more documentation in your code. But maybe you just need to fix your architecture because it's confusing. This, however, is the kind of documentation I usually see out of AIs. And I hate this. You do not need this. I do not need you to tell me that the name is a string that is the name, right? I can read. What I need you to tell me is name case sensitive? What fields will it check? Is it, if there's a space in it? What if it has multiple matches? I need to know all of those corner cases and side things, and how is this thing supposed to be used? AIs don't write those. They write, name is the name. And often those are worse than nothing, because once people see documentation, they never, ever replace it with better documentation. They go, oh, it stopped. AI is best when it's not a big deal if it's wrong. If the output is small enough that you can and will review it. For helping you with things that you could have handed to a junior or to like a new hire. Like if you can figure out this thing enough that you could hand it to a new hire, you can probably hand it to an AI. Right? Maybe you have enough documentation or it's clear enough. You have a clear statement of what you want. But anytime it has to be correct. Now all those things, they happen every day. I have lots of things that are like that, but if it has to be correct, if it can't easily be reviewed, then you don't want AI. It's the wrong tool. AI is kind of like a genie that can grant your wishes, but you need to know what you want. And if that is probably the most common cause I've seen of big AI projects failing. People start out, let's build AI, without ever figuring out what it was they wanted. What was the actual goal? And then maybe we could solve that goal without AI, if we focus on the goal first. Figuring out the goal and then expressing it clearly to a computer sounds kind of like programming. So I think maybe programmers have a career ahead of us, figuring out and talking to computers. So when I work with teams who are trying to create a new tool, the first thing I always tell them is do the task yourself once by hand. If you're trying to make like a tool, right, that's going to be AI based, do the task. So say you wanted to read all the trouble tickets and look, or the last week's worth of trouble tickets, and look for the root cause, the most common root cause. Do it. Like literally sit down, pull up the trouble tickets, and do it once. Is the information in the trouble tickets? And you go, well, I can't even figure out what the root cause is. I promise you, if you can't figure it out, neither can an AI. So don't build the tool yet. Like you need to fix something else. Very often I see people build all this elaborate search infrastructure, but there's no content. Make sure the content exists. So if I can leave you with just one thing, it's this. AIs are not computers. They're not people, but most importantly, they're not magic. They're tools that are good at solving a certain kind of problem, but if you've tried and kind of failed to get it to solve your problem, it's not you. It's that they don't solve all kinds of problems, and they often don't solve the problems your boss wants them to solve. I'm sorry. So let's see if we can find the things that they are good at. Do more of that. Thanks.
That was great. Does anyone have any questions? We've got a few minutes for.
Hey, you've spoken about AIs reviewing AI code. What about AI training data from AI code? Are we kind of getting to the point of no return where there's going to be enough data out there that sort of hitting that ceiling at this point, or do you think things are actually going to get better?
So the question is whether the fact that AIs are now basically eating their own tail because there's nothing out there that isn't AI, Well, there's no uncontaminated data. And what's the problems with that? Yeah, actually, I think that we are probably, personal opinion, I think the models we have today are going to be the grandparent models of every AI that will exist for 300 years. I don't see a time that we will ever be able to build from scratch a new large language model because we do know that they have a really hard time dealing with things that were output by AI. So yeah, I think we're stuck with these.
How much impact does spelling mistakes and stuff have on the response?
Yeah, so the question is how much does spelling mistakes and the like, or misstatements, grammar, actually shockingly little because of embedding space, right? AIs are actually really good at taking the fact that this group of tokens that's kind of jumbled up in the wrong way are still close to the correct spelling. So embedding, that's the point of embedding space. It's really a conceptual space. And it's somewhat like how humans do it, where we look at that and we go, yeah, okay, but it's really this other word. I mean, but think of it, it's not unlike yourself. It's not unlike a person. I mean, if it really, really confuses a person, but although it's actually, this is important for security. AIs are very, very good at unjumbling things better than people are. And that means that things can kind of sneak through because AIs can't tell the difference between data and code, like instructions and things they read are the same. They don't really have a good way to separate them, and they are very, very good at translating languages, derot 13 things, I mean, other kinds of scrambles, they can undo them really fast, and they can therefore get prompt injection. So.
At the start, you had the strawberries split up into different tokens.
Mm-hmm.
Presumably, when you have space word, if that's used as its own token,
Yes.
does it then take a mixture and say, I'm going to pass the token for space strawberry and the mixed up strawberry? Because otherwise, when would it split up a word?
Right. So I had an example, and I broke up, strawberry into three tokens or 4 tokens, and sometimes it was 1 token. And why would there be all those? Because if it starts with a space, which is a space followed by strawberry, is very common. Not having a space before strawberry is very rare. That's really rare. It's probably, I mean, it would happen like in the middle of, as by coincidence in random code, or because it's the very first thing in the document. The way they're usually built is the spaces are highly encouraged to be at the beginning of the tokens because that's how they operate. White space can stand by itself, but it's a lot less common. And in fact, the other thing is, like, a white space is a 220, but 2 white spaces is not 220, 220. It's a different token, a completely different token. 18 spaces has its own token. 78 spaces has its own token. 79 spaces has its own token. 80 does not. 83 does. So it's all based upon what it learned by reading the thing, although it is encouraged to put the space at the beginning.
You said that AI doesn't learn. Is only LLMs, or is there any AI right now that can learn? And is that the next frontier?
Sure. So the question is whether AIs that aren't LLMs can learn. I mean, machine learning systems learn if they have a training cycle. LLMs could learn if they had a training cycle. The problem is training cycles currently are both human intervention are high cost, both in human intervention and energy. They're very time consuming and power consuming. So we don't do it. Lots of systems though do, and in fact you can have a system that learns somewhat by, as it discovers something, writes into a file that you'll have come back later. But we don't have any systems that act like a LLM, a big generalized system that also learns. I don't think, it's not impossible, it's just, none of the current architectures do that.
What do you think about some tools that are adding like cursor rules or like repository instructions and kind of like writing documentation for these AI tools?
Yeah, so a lot of repos out there now. There's a lot of systems that have these AI rules directly into the repositories. So what's the impact? I think actually it's probably good, but I think it's all growing pains, right? We're all trying to figure out what to do with these tools, and personally, I think the current approach to coding agents is transitional, because frankly, I don't see it working. We need a new way. We need a thing to replace the IDE in order to. And so all of these 20,000 different Claude.md and README.md and LLM.txt, and there's so many of them. People are just kind of flailing around trying to figure out what to do. They do have a certain danger, though. It's become, if you reading things can cause the AI to prompt itself. So people have already shown attacks with that. So that makes me nervous.
So we are out of time, unfortunately, sorry, but I'm sure Rob's willing to answer some questions in person in a moment. So everyone, once again, thanks. Join me in thanking Rob for that fantastic talk.